So Tesla's latest full self-driving update, version 14.3, is out in the wild and it's causing a major stir. But here's the thing, this isn't just about a few new bells and whistles. We're about to dive deep into a fundamental engineering shift happening right under the hood. It's a change so big that it's unlocking some incredible performance, but it's also creating a massive divide among Tesla owners. You know, the first people getting their hands on this aren't holding back. They're calling it a giant leap. And that's what we're here to unpack. What does that actually mean? Not just in the code, but on the actual road. The feedback suggests a system that doesn't just act differently, it feels different. It feels, well, more confident, more human. All right, here's our game plan. First, we'll get into the foundational rewrite. That's the real heart of this update. Then, we'll see how that new code actually makes the car better at driving. After that, we have to talk about its biggest weakness, what I'm calling its cognitive Achilles heel. That leads us right into the great hardware divide. And finally, we'll take a look at what's next on the road ahead.
Okay, let's kick things off with the engineering, because the single biggest change in v14.3 isn't some new feature you'll find in a menu. Nope, it's a complete top-to-bottom overhaul of the car's software nervous system, and it all starts with the compiler.
Now, for any of my fellow software folks out there, this is where it gets really exciting. The key to this whole thing is something called MLIR. Now, you can think of a compiler as a translator, but MLIR is way more than that. It's like a whole team of hyper-specialized translators. It's a framework that's purpose-built to take these huge, complex AI models and just shred them into tiny, optimized pieces that map perfectly onto the car's custom silicon. It is all about squeezing every single drop of performance out of the hardware.
And this is the point that you just can't overstate. Tesla didn't just tweak a few things. They literally threw out their old AI compiler and runtime and rebuilt the entire thing from scratch on MLIR. This isn't like patching a bug, it's like tearing out the old foundation of a house to pour a new one that can support a skyscraper. It unlocks a whole new level of capability.
Okay, so a foundational rewrite sounds cool and all, but what does it actually do? How does all that fancy code translate into what you feel behind the wheel? Let's take a look.
And here it is. This is the payoff. That MLIR rewrite resulted in a 20% faster loop time. That's the speed at which the car can see something, decide what to do, and then actually do it. In the world of real-time computing, a 20% improvement isn't just a step, it's a pole vault. This number fundamentally changes what the car is capable of. And you can see that 20% in action right here. You remember the old infamous FSD double stop, right? The car stops way too early, creeps up, stops again. Well, that was basically a symptom of processing lag. With this new stack, it just sees the whole picture faster, gets confident about where it is, and commits. It does a single, assertive, human-like stop right at the line. It's a night and day difference. It is the exact same story with yellow lights. You know, before, the system would sometimes get caught in two minds, misjudge that point of no return, and just slam on the brakes way too late. That 20% faster reaction time gives it the breathing room to make that call earlier and more accurately. The result is a much smoother and, frankly, a much safer decision.
We're even seeing huge improvements in just basic driving etiquette. That annoying left lane camping habit seems to be gone. The system now has enough awareness to understand, okay, I'm done passing, and it moves back over. It's also showing more patience around exits instead of trying those aggressive last-second passes. And the list just keeps going. People are describing automated parking as flawless and way faster now. But the one that really gets me is the reaction to hazards. There's footage of the car reacting with unbelievable speed to a pedestrian stepping out at night. That 20%, that isn't just about comfort and smoothness. That is a direct, measurable improvement in safety.
But, and there's always a but, it's not a perfect story. While the car's low-level mechanics, its reflexes, are now truly world-class, its high-level thinking is still lagging way behind. It's kind of like having an Olympic sprinter who is absolutely terrible at reading a map.
This quote from a tester really just nails it. The big MLIR rewrite, it supercharged the car's ability to execute a plan, but it did nothing to improve the quality of the plan itself. It seems like the pathfinding and the routing logic are a whole separate, probably older part of the software that just didn't get the same ground-up overhaul.
And here is a perfect, almost funny example. If you turn on avoid highways, the system can get completely lost. Testers have seen it making a series of totally illogical turns that result in it just driving in a giant rectangle. I mean, it executes every single turn and every lane change beautifully, but the overall mission makes absolutely no sense. Okay, So that brings us to the second and honestly probably the bigger problem here. This giant leap in software performance has exposed a massive gap, and it all comes down to the computer that's physically sitting inside your car. So here's the deal. The new, much more powerful AI model that MLAR enables, it requires hardware 4, which you only find in the newer vehicles. This means millions of owners who have hardware 3 just don't have the memory or processing power to run it. They're now being told they have to wait until maybe mid-2026 for a light version. This will be what's called a quantized build, which is basically a compressed, lower-fidelity model. Think of it like a super high-res photo versus a compressed JPEG. It's still the same picture, but a lot of the fine detail gets lost just to make the file smaller.
And this is a really big problem. For years, the line was that the hardware was future-proof, that it was all just a software problem. Well, this update completely flips that script. It creates a two-tiered system where millions of people who paid for FSD are now being left behind, waiting years for a version that will, by definition, be less capable.
And let's be really clear here. Even on the absolute latest and greatest hardware, this is still a level 2 driver assist system. You still need to intervene, especially in tricky city driving. You still get some sloppy parking jobs now and then. And hey, no amount of software magic is going to fix a camera that's being blinded by sun glare. The physical world still has its limits. So, where does all this leave us? Well, we're at this really interesting moment where this brilliant piece of software engineering is smashing headfirst into the real-world limits of both its own legacy logic and the physical hardware it runs on.
Now, Tesla knows these are issues, and they do have a roadmap. They're planning to add things like pothole avoidance and make the driver monitoring better. But look at that second one. Expand reasoning to all driving behaviors. That is the big one. That's the key to finally fixing that cognitive Achilles heel, to making the car not just a better driver, but a smarter navigator.
When you step back, the story of FSD 14.3 is just a fascinating case study. It's a tale of a monumental software achievement that gives you real, tangible improvements on the road. But at the same time, it's a huge cautionary tale about the headaches of dealing with old code and the brutal reality of hardware fragmentation when tech is moving this fast.
And that leaves us with one last really big question. We're all used to our phones feeling old after a couple of years. But as our cars become more and more like computers on wheels and the software is evolving at this incredible speed, is the auto industry ready for the day when your 5-year-old car is just too slow to run the latest safety update? It's something we're all going to have to think about.